Today, we're diving into one of the most incredible pieces of biological engineering inside every single one of us, the hormonal clocks that run our reproductive systems. It's this amazing, intricate system of perfect timing and chemical conversations.
So what's really pulling the strings here? What's the master conductor behind this whole biological symphony? How does the body manage this incredibly complex rhythm, month after month, or in the case of males, day after day? All right, let's get into it.
So here's our game plan. We're going to start at the very top, at the command center, to look at the master controls. Then we'll trace that elegant 28-day female cycle and contrast it with the constant, non-stop process in males. And finally, we'll look at how we've actually learned to hack this whole system using contraception.
Now, you might think our story starts in the reproductive organs, but it doesn't. It actually begins deep inside the brain, in the hormonal command center that runs the entire show.
The best way to think about it is like a three-tiered system. Right at the top, you've got the hypothalamus. That's our mission control. It sends out the first set of orders to the pituitary gland, which acts as the relay station. And then, the pituitary broadcasts those signals down to the factories, the ovaries or the testes, telling them it's time to get to work.
And that very first signal, the starting pistol that kicks this whole race off, is a hormone called GnRH. It's shot out by the hypothalamus, and its one and only job is to travel a teeny tiny distance to the pituitary and basically say, hey, it's go time, release the next set of hormones.
And in response to that, the pituitary releases two superstar hormones, FSH and LH. Seriously, a great way to remember them is that FSH is the grow signal. For females, it tells the follicles in the ovaries to start growing. For males, it gets sperm production going. LH, on the other hand, is the go signal. It's that final trigger that causes ovulation in females and sparks testosterone production in males.
Okay, now let's see how all those signals play out in what is, honestly, a monthly masterpiece of biological choreography, the 28-day female cycle.
Now, what's so cool about this diagram is you can see how everything is connected. See the waves of hormones coming from the brain up top, and then in the middle, you see what's happening in the ovary, and at the bottom, the changes in the uterine lining. It's all one big, interconnected, cascading event. They all talk to each other.
We all hear the number 28 days, right? And yeah, that's a pretty good average. But it's so important to remember that for most women, a normal cycle can be anywhere from 23 to 35 days. It's when that timing gets really unpredictable that it can be a sign that the hormonal conversation isn't quite flowing right.
So the uterus itself has its own four-phase journey. It all starts with the menstrual phase, where the old lining is shed. Then comes the proliferative phase, where the lining, the endometrium, rebuilds itself nice and thick. After ovulation, we hit the luteal phase, where it gets all plush and nutrient-rich, just in case. And if no pregnancy happens, a very brief ischemic phase cuts off the blood supply, and the cycle starts all over again.
Meanwhile, at the exact same time, the ovary is performing its own little three-act play. Act 1, the follicular phase. FSH kicks off this big race, pushing several egg-containing follicles to start growing. Act 2 is ovulation. A big, dramatic surge in LH, our go signal, makes the one winning follicle burst open and release its egg. Then in Act 3, the luteal phase, the leftover follicle cleverly transforms itself into a temporary hormone factory.
And this picture shows that first act perfectly. You can literally see the cells around the egg growing and layering up, all thanks to FSH, that grow signal we talked about. It's this really delicate process where everything has to go just right.
So what happens after ovulation is absolutely crucial. That leftover follicle gets a brand new job. It becomes the corpus luteum, which just means yellow body, and its main task is to pump out progesterone. And it's progesterone that makes the uterine lining super thick and welcoming for an embryo. If this little progesterone factory shuts down too early, that can actually be a factor in some cases of infertility. All right, let's switch gears and jump over to the male system. We're going to see how it's built on the same hormonal foundation, but with a totally different strategy. We're shifting from a cyclical, once-a-month event to a continuous, non-stop production line. And the contrast here is just stark. The female cycle is cyclical, releasing roughly one mature egg per month from a supply that's finite. It runs out. The male process, spermatogenesis, is continuous. It churns out millions of sperm every single day, and that production can last a lifetime.
Now here's a number that might surprise you. Even though the factory is running 24/7, the actual journey for one single sperm, from a basic stem cell to a fully mature swimmer, takes about 2 months. It's a pretty long and complicated assembly line.
That whole journey starts with a special kind of cell division called meiosis. Its only purpose is to cut the chromosome count exactly in half. So after 2 rounds of that, you get 4 simple round cells called spermatids. They've got the right DNA, but they can't swim. So the final step is this incredible transformation, kind of like a tadpole turning into a frog. These little cells grow a tail, shed all their extra weight, and become the streamlined swimmers we all recognize.
So we've got these incredibly intricate, self-regulating systems. And for the last 60+ years, science has been figuring out how to consciously and safely step in. So let's take a look at how we can actually hack the system.
The basic idea behind hormonal contraception is actually elegantly simple. It works by giving the body a steady, low level of synthetic hormones. And that basically tells mission control up in the brain, hey, we're good down here. We've got enough hormones. You can take a break. And that just interrupts the whole natural cycle of signals.
And to get more specific, the synthetic estrogen in the pill blocks FSH, that growth signal, so that whole race to the top with the follicles, it never even starts. Then the synthetic progestin is like a triple threat. It blocks the LH surge, so ovulation can't happen, it thickens cervical mucus to create a physical roadblock for sperm, and it keeps the uterine lining from getting too thick.
But here's what's really fascinating. By controlling these hormones, we can do way more than just prevent pregnancy. These medications are used all the time off-label to help manage irregular periods, provide relief from painful conditions like endometriosis, or treat symptoms of PCOS like acne. It's become a really powerful tool for managing a person's health.
When you just step back and look at the whole picture, you see these 2 systems, one that's cyclical and careful, the other constant and prolific. They're really just 2 elegant and fundamentally different solutions to the exact same biological challenge, continuing the species.
And that really leaves us with a final thought to chew on. As our understanding of this intricate hormonal dance gets more and more detailed, what comes next? How might we fine-tune our approach to fertility, to our overall health, and to the very concept of family planning in the decades to come?